Today on Crude Confessions, Jasmine and I are going to be talking with Greg Batten a little bit about coolant. I know that a lot of people think coolant, they think automobiles, they think trucking. There's a lot more to coolant than just the basics. I'm sure if you're in a different industry, you're already aware of all the other uses for it. Think about aerospace. I think about construction. I think, who else do you have, Jasmine, that's using coolant?
Everybody really, and it's funny because it kind of goes back to the whole grace thing last week that we had. They kind of look at color again too.
Yep.
So, is that still relevant? Sometimes I have some customers or people that say, well, this isn't the same stuff. It's not red. And so I think this is another one of those times when we're like, okay, what can we actually use as a marker to make sure you're using the right cooling?
I have a customer that does aeroponic growing, and part of their cooling system that they use is coolant, and they just keep telling me they need the red stuff, the red stuff, the red stuff. But different brands make compatible products that aren't the same color. So you're right. What is the marker? What is considered the new stuff? Because the red stuff used to be the new stuff.
Mm-hmm.
So,
Jasmine, I think you had a customer who had decided upon one type of coolant, and when it arrived, it wasn't the right color, and his folks who were running the shop said, no, it's the wrong stuff.
Right.
They sent it back. So yeah, it does. I'll just give a little insight into that. So color historically has been, like in the animal kingdom, the warning sign, right? If there's color, even for us in the category of coolant or grease, as we talked about, it gives folks a reason to pause and go, am I mixing the wrong things? And the reason for this, historically, we've had such radically different additive packages for automotive, for heavy duty, for different industrial applications, that if you mix the wrong things together, you would truly have a catastrophic, might be too harsh of a word, but a significant chemical reaction, because the additive packages, not the water's not going to have a problem, the glycol's not going to have a problem, but the additives are going to have a problem. And we know from just basic chemistry, you mix a couple of wrong things together and stuff boils over, or stuff firms up, or whatever it might, or turns acidic, or turns basic. And so by changing by having different colors, they do prevent people from putting the wrong, unintentionally mixing different additive packages. So great opening comment about color and how the role that it has played.
Perfect. Well, Greg, we're actually just going to toss it over to you to take it away.
Okay, well, I appreciate it.
Now they have to been here.
Didn't mean to jump in early, but I really am excited about coolant, because like in so many areas that we've talked about over recent weeks, there have been significant changes. And we know people are slow to take up the new and improved, because we all gravitate toward what we understand. If we understand the old, even if we're not sure it's the best, we might be hanging on to the old technology because at least we understood it, right? Everybody wants to improve their lubrication process, their cooling process, so their whole program. Nobody wants to get fired over it because they made the wrong decision. They just blew everything up. So hopefully our talk today will help people understand a little bit of the history and connect it to where we're at the present and what's happening in the future. And so give me a moment. I'll set up my slide. I guess the first thing I need to do is hit the share button, and I'll go to my screen. And
while Greg's setting it up, I will say that coolant to me is probably the most important thing for a vehicle, for anything else out there, because when I had my first car, I blew up quite a few radiators because I was putting the wrong stuff in there, because the guy at AutoZone told me this one works for all things.
And they say it's actually one of the main causes of failure, right, is the coolant?
Yeah, I'm going to swap my presenter view so that way it looks like I know what I'm doing here. And I think that you're seeing my primary screen. You're absolutely right. I see statistics all the time, and they range from 30 to 40 to 45% of all engine failure is coolant related in some way. And that's going to vary by business, by industry, by nature of work. But I don't think that those numbers are too far off from the real experience that your customers will have, is that it's not like, well, I mean, just think about it. If you've ever driven an RV or pulled a load or whatever, you're constantly, in your own personal vehicles, pulled a trailer or something, you're constantly watching the radiator temperature, right? You're never thinking, I wonder if my oil's breaking down. You're thinking, I wonder if my motor's getting overheated, right? So Jasmine, your point's right, that it's a huge double-digit percentage of problems for coolant. That coolant represents, or radiators represent, for engine problems. Okay, I'm going to kill my video, and I'm going to, if I can figure out how to do it, and maybe I won't. I think we'll just go with this. All right, so we're discussing coolants today, and again, the following is just a discussion. It's not really a formal training, and as such, my comments, my answers, my analogies are not all approved. Okay, stop video. That's what I want to do. They're not all approved by Valvoline's legal, technical, and marketing teams. So no one should consider this a product recommendation specific to their application, but instead just think of it as an informed opinion. And when my son saw what I was working on, he said, "Dad, you need to get a little more hip on the title. Maybe it should be something like 'Never Too Cool for Coolants.'" And I said, "Well, I think I'll just stay with it." But he said, "Put your Valvoline hat on sideways and run with it." Anyway.
That should be on our next call.
I'm in charge of marketing.
I'll let him know. So yeah, again, even though I'm calling it a discussion, I'm moving pretty fast. But if anybody has any questions, feel free to jump in, break in, and we'll do that. Like always, since it's not a true training class, sometimes you're going to see the answers even as I'm asking the questions. So let's go to the first question. What is the primary purpose of antifreeze coolant? And then our pre-conversation to the training here, we talked about it, right? It is to transfer heat from the engine, because basically, pure and simple, if the cooling wasn't taking place, the engine would burn up, and all the other benefits of coolant that we'll be discussing today would be meaningless. So we've got to draw that heat off from the engine, put it into the radiator, exchange it out into the atmosphere, and let the coolant recirculate, and do it all over again, time and time again. So what are some of the other additional purposes of coolants? Well, some of the things that they do is they prevent freezing by lowering the freeze point. And on the other side, they elevate the boiling point to prevent boil over from just straight water. They protect against chemical corrosion, and we all understand that. We understand acids and bases and how they eat metal up. But they also prevent mechanical corrosion, and one form of that we'll talk about today is cavitation, right? So it still is eating away at the metal. One's chemical, one's mechanical, preventing foaming, a few other things like conditioning the seals, the hoses, all of that. There's a lot of things that coolant can do, but the four major causes of failure in a cooling system are the four that you see there. The seal, corrosion, deposits, and freezing and boil over. So all of these areas require a quality antifreeze coolant. And when I use the word coolant, it's synonymous with antifreeze. And when I use antifreeze, it's synonymous with coolant. Just depends on which end of the thermometer you're at that particular time, right? But they all require a quality coolant to prevent this failure. And you can buy coolants with cheap glycol, because you can recycle glycol, and it takes a lot of energy and expense to bring recycled glycol up to virgin quality glycol level, but you can do it. Or you can buy coolants with cheap additives, right? And that's why there's a lot of very inexpensive coolant out there, because they're either using cheap processes, cheap glycol, or cheap additives. But all you're doing when you buy that is you're buying future trouble, and you're buying premature coolant system failures. So we want to avoid buying things that we don't know of. So the first one we're going to talk about here is freezing and boil over, because that's what most people think of on coolant. So this is a fairly common chart. If you look in the upper left, you'll see that it talks about, let's see, my cursor is working, that water at 100% freezes at 32 degrees. Most of us know that. If we go over to the right, we see that glycol at 100% freezes at 8 degrees. Well, neither of those are really good if you live up in the Dakotas, or if you live in Alaska, or even if you live just in some of the Central Plains states, right, where it does get down into the -20s, -30s, or occasionally even worse than that. But a wonder of chemistry is if you mix water and glycol, you drop this freeze point. It goes down to 0 to -10 to -20, -30. This chart would indicate you can get down to -90. I've actually not ever seen that. I've seen 60s and -70s. So I don't know if this is a representative or if this is truly a low point. But basically, what this red shield is saying is there anywhere between a 40-60 and a 30-70 ratio is fine. You're close enough. So as a simple approach, generally we say go 50-50. It's kind of easy to think 1 gallon of this, 1 gallon of that. Now I got 2 gallons or mix 50-50. I know when my customers up in Alaska, they do want different concentrations. They do want 60-40s or 40-60s or 30-70s or whatnot. But anyway, it's good to know, and that's why we recommend 50-50. Generally, I recommend just buying the pre-mixed because everybody's water is different. If you live in an area that you have to deal with calcium scale in your shower or around your sinks, that water is not good for mixing into your antifreeze. And there are some regions of the country who have fantastic water, but the majority of water in our country is pretty crummy. It's got a lot of hard minerals in there that just are not appropriate to be included into your cooling system. So pay the money, buy the premix, and reap the long-term benefits of that. So one of the other major causes of cooling system failure is corrosion. And so corrosion, as I mentioned earlier, can be chemical, and it can also be mechanical. We're going to talk about mechanical just a little bit. So this is a bubble that is beginning to collapse. And as you can see to the left in the red circle, there's a label that says it's a microjet. I'm told that these microjets produce pressure up to several thousand PSI, pounds per square inch. Now, if it was just one bubble, that wouldn't be a big deal. But these bubbles are generated by the hundreds, if not thousands, constantly by the vibration of a piston going up and down in the cylinder of a diesel engine. And when they explode, they are individually and collectively blasting the surface of the engine metal with this high pressure, this high PSI. Specifically, the cylinder walls where the coolant is supposed to be doing good things like drawing the heat off from the combustion chamber. These bubbles can also form in the form of cavitation around the water pump. And again, when they're forming and releasing or breaking, they are bit by bit blasting away the metal around the water pumps. That's why you sometimes see a lot of that. So this is an expanded view of that whole cavitation process. And what you see here is, supposed to represent the hundreds or thousands of bubbles that are creating. And then over here microscopically, you see as the bubble breaks and it blasts the water jet in, it just blows out just a little bit of the metal right there. Well, what happens is when this process goes long enough, it looks like this next slide. And this is called liner pitting, because this is the liner, the piston would sit inside of it. The coolant is on this outside, and you tend to have all of these little holes blasted away. Well, initially it's not a big deal, but over time, those holes, like little pinholes, get blasted all the way through. And so now coolant is coming from this outside into the interior of this cylinder wall, and it is now becoming part of the combustion process. And you're getting coolant into your oil, you're getting coolant into your exhaust, going into your diesel particulate filter, et cetera, et cetera. So we definitely want to avoid this liner pitting at all costs. So generally, historically, the way that we have prevented this liner pitting is by coating this outside layer with additives. So the question is, do additive packages last forever? And that answer is no. Additives get exhausted over the course of time. And it's important to regularly test your additives and ensure that you've got a adequate supply of additives in here, or else you're going to lose that protection and this liner pitting is going to occur. Again, cheap coolant is not going to have good durable additives to keep that whole water bubbling process from blasting holes, into your cylinder wall, right? So you got to make sure that you're using a good coolant and an appropriate coolant for the design of your motor. All right, too much is a good thing. We're asking folks to become chemists and all of a sudden make sure that they're testing their coolant, keeping the right balance of the additives in there. And sometimes we can overdose. And if we overdose it, what happens is now those additives fall out of solution and they become part of the problem. Or maybe again, mixing the wrong additives cause the metal to begin to degrade. And now you've got little metal particles beginning to float around and eventually settle and block the various channels in your cooling system. So let's talk about just some of the basics. What does a gallon of antifreeze look like? Well, 96% of it's going to be glycol and water, 50-50 ratio. And the function of that is to prevent either freezing in cold weather or boil over when the motor gets hot. About 2% are the additives that control, they're called buffers, and they control the pH levels. And about 2% are the corrosion inhibitors, and they protect the metals. And again, that's corrosion inhibitors from chemical corrosion or mechanical. Freeze protection due to the water mixture, and the success in heavy-duty business depends on the quality of the ethylene glycol and the additives. We go cheap, we pay for it long-term. So a little coolant history. Well, the first thing that we had was the fully formulated, and it's oftentimes called the original green. I can't tell you how old this product is. I don't know if it's 50 or 60 or 70 years old or maybe older, but it's been around for quite a while. I mean, first it was just water, and then they began to put additives in there. So long time. Then we had the next generation called the extended life coolants. And generally folks know that as the red extended life or ELC coolant. And that came into play back in the late 90s. Texaco and Caterpillar designed this because Caterpillar had equipment all over the world, and the green formulation, people were putting it in there and leaving it for forever. And they were having all the liner pitting problems that we saw, among other water pump failures and whatnot. So they worked and designed this new platform of coolants. Well, it was great. It's been a great workhorse for our industry for several decades, but the product now is at least 20 years old. So the newest generation of coolants, the one it's pretty exciting, and I say new, it's already about 5 years old, is this nitrite-free. It's an organic acid, and it doesn't have some of the additives that the prior generations had. So color becomes less of a concern because you're not at risk of having the additives conflict with one another like we used to have. So we'll go on a little bit, talk a little bit more about the history. So we're moving away from inorganic acid technology to what's called organic acid technology. So
Greg,
inorganic.
good question in the chat. Are all of these compatible with each other, or would you have to flush your system to switch different types of coolant?
Yeah, great question. So historically, the answer would be no, they are not compatible. And again, that's why they're different colors, so that people pause and they do their research to make sure that if they're going to be adding different products on top of each other, that they're not going to encounter a compatibility problem. It's possible that you could mix a green with a pink or a pink with an orange or whatever, but you just got to be sure. You want to be sure. Now, this newest technology, because it relies less on additives and more on acids, does bring in a great measure of compatibility. Now, I'm talking with Valvoline slides and about Valvoline products, because those are the ones I work with and those are the ones I know. I think that to a large degree, my comments would extend to my competitors who also make these type of products. But I don't want to overreach and state that just because Valvoline is, yes, compatible, that everybody's newer generation of product is compatible. So take that with a little bit of caution. If you're happening to be used, one of my competitors' products, that you might have great flexibility or you might not. You just need to be absolutely sure. And again, Marissa and Jasmine can guide you in that, right? They can help you make sure that what you're using or considering using will in fact meet your needs. So IAT is the acronym for inorganic acid technology. That's the old green stuff. You can see in blue it says a lifespan of 3 years, 150 miles. When I was a young man, that number was 1 year and 50,000 miles. So even the additives on the green coolant at least Valvoline's green, has really taken a step up in the last couple decades, right? And again, it's the oldest of all the technologies. So then the more recent technology is the nitrided or inote, N-O-A-T-E, note or inote, as it's sometimes called, and that means nitrided organic acid technology. So it's the extended life coolant product, and it has a 3-year, 300,000 mile. And then what you can do is you can put the additive package, the SCA supplemental coolant additives in there, and you can go another 300,000 miles as long as the chemistry is right. And 600,000 miles, is kind of a typical number. You'll see products that say 750, even some that will say 1,000,000, but they all require this maintenance of additives after a certain point, generally to be regarded at about 300,000 miles, because you just don't want to let this stuff go in forever. Reality is most water pumps don't last 1,000,000 miles, and people are changing their coolant out anyway. So at some point, after a certain point, maybe 500,000 miles, 600,000 miles, whatever the number is, it's just throw away, because you're not going to really get that point anyway. But it combines the conventional and organic acid-based chemistry. It combines the newer organic acids with the older additive packages. And as the last line says, it lasts longer than the inorganic acid technologies, the original green stuff. The acids deplete slower. That's why it has the name extended life, right? Because it's a lot longer than the other one. So the newest product is what they call the nitrite-free organic acid technology. And it's much longer. It goes 6 years, 600,000 miles, 12,000 hours if your operation is based on hours, and you don't need to do anything. It's got this non-depleting acid technology. So it's got the compatibility, Marissa, that you asked about, because it's based less on additives and more on acids. And one way that I describe that is, if I were to take a steel post, drop it into zinc, pull it out, now I have a coated steel post. We commonly call that a galvanized fence post, right? A good quality one could last 20, 30 years before it starts to rust. A cheap one might start rusting in 5 years. So acids, even in that application, additives quality matter. Whereas the acid technology is more like if somebody put a brass or bronze statue in a park, or a copper roof on a pavilion, or a boathouse. It's bright and shiny today. After a few weeks, it starts to get dull. After a few months, it starts to get like a green patina on it. But once that protective patina is established, how long does a statue last in a park? Hundreds of years, right? So that's what we're seeing here, is you get that protective coating that we saw as being necessary on the prior slides when we're talking about the liner pitting, the cavitation. But you do it with acids, not with additives. Now, I'm going to go on to one more slide that I call my some folks just got to know. Let me see if I can get there. Oh, my screen has frozen up. There we go. So some people like to go, well, just exactly what are these additives that I see in here? And you're going to see reference to carboxylate acids. You're going to see things like sorbacic, several other types of acids that you'd have to be a chemist to know. And it talks about some of the additives. So some of your folks are going to want to snap a picture and study this when they're looking at it. But really, it's just chemical composition. So let's move on just a little bit. So why are these this new technology needed if the extended life coolant has been so good for so long? Well, the reason is contained within the screenshots here. These are some articles that I cut out several years ago when this was all becoming new. And you can see highlights on things like the word aluminum and the first thing, or nitrite-free organic acid here. Aluminum is replacing steel because of its high strength, low weight. Continuing on, nitrite-free in aluminum. You can see that date is 2017. That was over 3 years ago, right? Coolant with nitrite organic and acid react with the flux used to braze aluminum parts together. And it goes on to talk about metal corrosion, et cetera. And those are with some of the old additives, nitrite as opposed to the newer stuff, which is nitrite free. Organic acids don't deplete. So going back 3 years ago, there were already industry journals talking about how we need to be moving away from our older technology into our new one. And even Detroit published in the first quarter of 2015, that's 5 years ago, Daimler Trucks North America will be changing from nitrite organic acid technology to, or extended life coolant, to the nitrite-free organic acid technology. And under the Y, Detroit diesel testing has demonstrated that nitrites contained in the older the NOAT technology can cause a breakdown of the coolant. So even though your customers and those viewing this may still be using red, the reality is that most engine manufacturers began 5 years ago this conversion away from the old ELC to the nitrite-free. Cummins has a newer spec. It's 14636. We just saw the Detroit spec on the prior screen. And we can also see on this screen that a lot of folks are now shipping their trucks out with nitrite-free. John Deere, Volvo, Agreco, MAN, International, Mercedes-Benz. So this nitrite-free is really growing. And some of your customers have made the mistake of sticking with red, even dropping the brand new nitrite-free coolant and going with the red extended life. So just a few more things. So this is Valvoline's lineup. We've got the red original green. You see the 3 years, 3,000 hours, 150,000 miles we talked about earlier. The red, 3 years, 7,000 miles, 6,000 I think is what it said on the, or 6,000 hours is on the prior screen, but it's now up to 7. 300,000 miles, then we recommend putting in the supplemental coolant additive booster package. The nitrite-free, you can see, goes 6 years, 12,000 miles, 600,000 hours. You can see that the older stuff met some of the older Cummins and Caterpillar and Detroit Navistar spec, whereas the newer products meet the latest. They meet all the old ones, but the latest as well. So again, backward compatibility is one of the great things about this nitrite-free. This is backward compatible with red. It's backward compatible with green. It's backward compatible with pinks and orange. Any of the additive technology that preceded it, because it's not additive base, it's acid base. Jasmine, you talked about failures. Here's my slide. About 45% of all engine failures are coolant related. And one of the reasons, especially now, is that these new motors just run so much hotter because they're trying to get better miles per gallon and better horsepower per gallon improvements, as well as green gas reduction as well. Heat transfer, corrosion protection, oxidation control, that's a word that we're hearing more and more of these days as motors run hotter and oil drain intervals go longer, is controlling the oxidation. And that that's appropriate not just in engine oils, but it's appropriate in controlling the oxidation of the metals as well, or the coolant itself. So a lot of good benefits to this new acid technology. Anti-scaling, if you don't have a lot of additives in suspension, there's not a lot of additives to fall out of suspension and to settle on the bottom. There's not a lot of additives to cause scaling or deterioration of the softer metals such as aluminum and copper and brass as well. Pause. Anyone got any question on the last couple slides?
Oh.
Marissa, you're on mute if you were.
I caught that. Shoot.
Yeah. Okay.
I could hear a delivery truck coming, so I was muting myself so the dogs didn't bark.
So sorry guys, I have my coworker here who's trying to bombard our chat. So sorry.
Oh no.
A 5-year-old or a 5-year-old. That happens. That's today.
The charm of working from home right now.
I know. We're all kind of just trying to do what we can at this.
Absolutely. No, that's cute. All right. Well, I'll go on if there's not a specific question.
I think Marissa had a question.
Yeah.
Go ahead.
We got was that he wanted to know the risks of using a recycled oil, or I mean, not oil, a recycled coolant. There's a lot of companies out there that are offering that as opposed to using something new. What are the differences they're going to be getting between the two?
Yeah, I've had several situations over the last 5-10 years where I've approached a customer on coolant. Big companies, grocery store chains, or maybe 20 or more rock crushing facilities, aggregates companies. And they've said things like, well, your competition's coming in with this coolant and it's $4 a gallon cheaper and it's recycled stuff, right? I'm like, yeah, I get that. And, we can do some tests. We can tell you the quality of what they're doing and you can make your decision. And in at least two cases, I can vividly recall, they both said, we haven't had any problems yet. We're going with it. Well, within a year, probably more like within 8 months or six, I've gotten a call that said, okay, we've learned our lesson. We now need to buy the good stuff, right? So you can buy the cheap stuff. You can save a lot of money on the front end, but almost no amount, even if they gave it to you for free on the recycled stuff, is going to justify the expense of replacing motors prematurely, just because the whether it was the glycol or the additive package didn't hold up or was the wrong stuff. I mean, the recycled stuff is going to be using a lot of very old green technology, a lot of pretty old red technology to make a product that may or may not even be good enough to start with. So it's a bit of a risk. I'm not saying that nobody out there is making good recycled stuff. I just don't encounter it on a regular basis.
Another question came up. So is there anything that they can do to actually understand if they're using, I guess, what the performance is of the current coolant
Sure.
they're
Yeah,
using?
just like taking an oil analysis, you can take a sample of the coolant and send it in. And if you send it into some of the labs that we currently use, they're just going to give you the data. If you would like an opinion, we can certainly send it into Valvoline's lab directly, and they'll analyze it and they'll give you an opinion is essentially what it is. It says, here's what you got, here's probably how long it will last, and here's what it's probably made of. And uh, you're welcome to do that and encouraged to do that. I mean, if somebody, it's a fairly inexpensive test, and yet it may show somebody that they've got a great deal. So if you are want to go down that process, we can certainly assist you by just collecting a sample and sending it in. Okay. All right, I'm going to kind of move on just a little bit, just a couple more slides. And again, Valvoline's newest product, this is actually a several-year-old slide because we've had it out now for 5 years or more. But what I really like is in blue, that fill it and forget about it. It's such a long-lasting product that you don't have to use the test strips. You don't have to look for molybdates because they're not in there. You don't have to look for silicates. They're not in there. You don't have to look for nitrites. They're not in there. There's just so much that was in the older technologies that are not needed in this new technology that you literally can put it in and forget about it without having to spend money on filters that have little recharge pellets or whatnot. If you've got those in your inventory, you can use them up and be done with them because there's no conflict, but they're certainly not needed. No SCA is needed or recommended. Again, it's a non-depleting product, organic acid base, so it's highly compatible, both backward compatible and in the future. So if somebody in the future is out on the road and they just need to go and grab a jug of something from a truck stop or a Napa store or wherever, they can do it without risk of fouling up their current coolant that process. Offers double the extended life, the current extended life without adding the additives in there. Enables fleets to simplify inventory. So this is one thing we're going to talk about on the next slide is these, at least Xerox, and I suspect that competition does too, to some degree. These Xerox nitrite-free products can be used in light-duty cars and trucks, in heavy-duty cars, heavy-duty trucks, in on-road and in off-road. So if you're talking with a construction fleet that has on-road haul trucks, off-road dozers and scrapers, pickup trucks, and some company vehicles, they could literally use this one nitrite-free product in all of those particular items. And that is a big relief because so many times in a shop, they're looking, I've got 3 or 4 or 5 or maybe 6 different coolants here. Some for the Ford truck, some for the GMs this, some for the Caterpillars that, some for the Detroits or Cummins motors for our on-road. And having one product, it makes life simpler, You're not going to run the risk of putting the wrong product in the application. You don't have inventory just sitting stranded collecting dust because nobody remembers why we bought it or what it goes to. It's just really a good product. And the last line makes it easier when selecting the proper coolant, especially if it works for all makes and models. So as you see on this last slide, up at the top, encircled in yellow, you see that we've got categories for GMs and Fords and Chryslers and Toyotas and Cats and Fords and Dodges and Cummins and Detroit, and it goes from the light duty to the heavy duty. And in the middle of the screen is our Xerox nitrite free. It's a yellow product, but you see we either have approval letters for all of those categories, light duty or heavy duty, or we've got a check mark. And a check means that we are recommending. In many cases, it means that we've got, let's look at PACCAR, for example. That's about on the right side. You can see we've got a couple of approval letters for a few of our products. And because we know what PACCAR's test threshold is, and we know the chemistry, we can just extrapolate and make a check mark or recommendation. So if Valvoline makes a recommendation, that means that Valvoline is confident that this product will work, and either we're in process of getting approval, or that we know enough that we can make that recommendation. And of course, anything that we recommend, we back financially. We're not going to make a recommendation that we're not going to stand behind as well as far as that. So it's just a great product, this whole new technology, in terms of long-lasting, ease of use, compatibility, and also, as this chart shows, the suitability there. So that really concludes my my presentation about coolants and the new generations, a little history lesson and a little look forward. Any other questions?
Yeah, let's talk about how to store it. If it's not in cases and it's not being delivered in drums, if someone's going to keep it in bulk format, what are the best practices for storage?
That's an interesting question. I don't think there's anything specific. It's not like it's DEF and you've got to temperature control it or keep it out of the sun or whatever. Although it makes sense, right? No reason to let UV rays cook it, because UV tears up everything. So yeah, I would keep it inside. I don't think you have to be particularly fussy about temperature. Obviously, you want to keep it sealed so you're not either getting contamination, either in the form of moisture or in the form of dust or dirt in it. But it's really quite simple. Nothing special about it. Anything different than how you would just store and distribute traditional coolants, antifreezes.
Does it require a poly container of any sort?
No. Yeah, you can. No, it comes in. You see it in metal drums. You see coolants in poly drums. Certainly plastic jugs. So yeah, it is not. It's got a pH 7, 7.5, 8, something in that range. And as you were to get into the late innings of its life, in the 10, 12,000 hours, you might see that pH drop off into the 6 or whatnot. But even that's not considered to be particularly acidic. Any other questions?
Do you see any other questions, Jasmine?
No, I don't see anything. But going back to it, so you know how when we were talking about backwards compatibility and everything, with that test, if they were to do the coolant test, would that help them determine it, or would it just be kind of just off of what they're using? They would just, let you know what they're using. They
Right.
could just know what they're using.
So,
there's no way they can do that themselves, really.
I can say with a high level of confidence that the Valvoline Xerox nitrate-free product is backward compatible with everything.
Okay.
It's not going to be a conflict. And again, the reason is it's because we are not putting additives on top of somebody else's additive package that might have a chemical reaction. We're putting acids on top of additives, and there's no reaction going on there. The problem is the quality of the other products. So let's say you've got
Right.
somebody that's got an old tractor and it's had green coolant in there for the last 5 years. Doesn't run it much. It's just been sitting there. Runs it a little bit. If you put the nitrate free on top of it, it's not going to be a problem. The problem is going to be, how good is the green coolant that's in there? So you
Right.
evaluate that. Has the existing stuff just worn out, and is it just a good idea to dump it and to put the new one in? The contra to that would be, let's say that somebody just replaced a radiator and just put new red coolant into a unit last month. Well, they don't necessarily want to throw that away. That's a lot of money in there. So yeah, you could just put the yellow nitrite free right on top of it and be very comfortable that that product is going to last for 300,000 miles. Now, in the next 300,000 miles, you're going to have some boil off. You're going to put some more nitrite free on top of it, and you know, as you're several years down the road, you might want to do a dump and conversion. But
Right. So
just,
best practice would maybe just to be aware of what was in there first, because the stuff isn't going to like rescue it or anything.
exactly, that's right. That's
It's not going to magically make it all better.
it's like the weak, yeah, it's a chain, right? You're only chain as strong as the weakest link, and in that case, the old product, whether it was recycled or just old,
Right.
is the link.
Okay. Okay.
Well, great.
Got
Thank you so much for chatting with us again.
Well, you're welcome. Always a joy to participate in these, and thank you for the opportunity just to share a little bit. I look forward to answering any more questions that you or your customers might have.
Next time we meet, we'll be chatting about preventative maintenance. So I'm looking forward to that one as well.
Yep. Putting all of this together.
All right. Thanks, ladies.
Thank you.
Thank
Bye-bye.
you.